We are continuing with polygons today. And I'm going to quickly do this first opener. How many sides does a polygon have if each of its interior angles is a measure of 160? It says each, so that's a key word there. So that means 160 times n, that would give us the sum of the interior angles, right? Well, we know that our formula is 180 times n minus 2. So what could I do here? 160n equals 180n minus 360. Move the 180 over. N ends up equaling 18. It's asking for how many sides. So we're actually done, 18 sides. This next rest of the opener stuff, I think you can do yourself. Not that you couldn't do number one yourself, but you can check the answers with what I post on Canvas, okay? Deep thoughts. This is a takeoff of a Saturday Night Live sketch from years ago. It was a pretty lame sketch, actually. But if a triangle is equilateral, then it's also equiangular. Again, if you want to try these first, pause this right now. You can. This would be yes. If a triangle is angular, then it's also equilateral. That's yes. If a quadrilateral is equilateral, is it also equiangular? Excuse me. Clearly, that's a no, because an example would be a rhombus, right? And here, if a quadrilateral is equiangular, it's also equilateral. That's no as well, because a rectangle is equiangular but not equilateral. If a pentagon, if a hexagon is equal, does it imply the other? It's no. You can start playing around with this and messing with some of these drawings if you want, but it doesn't have to be a no. It's just the triangle that's unique in that way. Okay. Okay. So speaking of equiangular, and remember, equiangular, equilateral, that means regular. Regular means both equilateral and equiangular. Okay. So here we got a regular polygon. Find the number of sides. We'll get to that in a second here. I forgot, I wanted to share this formula with you up here. Because if it's regular, means equiangular. Remember, the sum of the exterior angles in any polygon is always going to be 360, okay? So if we take 360 and divide the number of vertices, that'll give us the exterior angle of any regular polygon, because in a regular polygon, they're all the same. So this formula is going to be very helpful, right? Okay. So we can use, this is if an equiangular polygon. And clearly regular is equiangular. So all we have to do here, now we can manipulate this equation. Remember, if I cross multiply and I can solve for n, and 360 over the exterior angle measure would give us the number of sides. So this would be 15 sides. So remember, this, you can manipulate this. 360 over n equals the exterior angle measure, but 360 over the exterior angle will also give you the number of sides. Same formula, right? Find the name of the equiangular polygon if each of its angles is 140. Remember, it just says angle, so that implies interior. So if the interior is 140, the exterior angle is always supplementary to it, so that must be 40. 360 over 40 equals 9. Now remember, this asks for the name So your final answer here would be a nonagon because it's got 9 sides. All right. So on the back side here, find this. This is just the page number, that too. Don't worry about that. The sum of a polygon's angle measure is 10 times. Oh, this is a good one. You got to do some translating here, right? The sum of a polygon's angle measure. So that's all of the angles. So that's 180 times n minus 2. Remember, it just says a polygon. Whoops. Is equals 10 times the measure of an exterior angle of a regular pentagon. Well, the exterior of a regular pentagon would be 360 divided by 5. Now, through the magic of canceling, that becomes a 2, right? And then I have 2 times 360 is 720. I'll divide both sides by 180. I get n minus 2 equals 4. So n must be 6. So that's a hexagon. Okay. So you get the idea here. I mean, the rest of this is just practice. Realize, and this, I'll do this octagon, this BC, because it goes from one vertex and there's an even number of sides here, even number of vertices. You're going straight across the figure. This is a line of symmetry. Okay. BC is a line of symmetry. Find the measure of angle ABC. Well, remember, 360 over 8 will give us 45. That's the exterior angle. So the interior angle must be supplementary to that, so it's 135. So this angle right here is 135 degrees. Now remember, this is an isosceles triangle, right? So what do we have to find? Angle ABC, because it's isosceles, angle ABC would be 22.5. I'm not really sure why I even did that whole line of symmetry thing, but it's something to keep in mind. That is a line of symmetry. You didn't really need that to do this problem. Oh, wait, my bad. Let me fix this. What I found, the 22.5 is this angle here, right? I wasn't paying attention to the question. So if I call this point D, angle DBA is 22.5. So angle ABC would have to be 45, because remember, this big angle here was cut in half, so you did need to have that line of symmetry idea. All right. Number 5, you can take a look at. You can try it yourself and take a look at on the answer key that I'm going to post. It's going to give a rationale there. Number 6 as well. I'm not going to do that one. Let's see. I'll quickly do 7 and 8, and you can do 9 yourself. Okay. If the measure of an exterior angle at the vertex of an isosceles triangle, so remember it's at the vertex. So let's say we have a triangle like this. If the measure of an exterior angle is 4 times as large as the measure of the J, so if I call this one X, we're saying this is 4X. Okay. How large is each angle of the triangle? Now remember, this exterior angle, don't forget about our exterior angle rule. The exterior angle of a triangle is equal to the sum of the remote interiors. And we know that these two angles here are congruent. So if that's 4x these both have to be 2x. So we have 5x equals 180, x equals 36. You can figure out the rest of the angles, 36, 72, and 72, right? Number 8, an exterior angle of a regular polygon is 1/5 the measure of an interior angle. So instead of using fractions, which angle is bigger? Exterior angle 1/5, so the interior one's bigger. I'm going to call that 5x. I'm going to call this one x. We know that interior and exterior angles are always supplementary. So x equals 30. And what are we asked to find here? The name of the polygon. Okay, that's the exterior angle. So 360 over 30 gives me 12 sides. Dodecagon. Rest of these will be on Canvas, okay?